Lesson 7K, Full Atwood Machine Frictionless. Remember, an Atwood machine is a two-body system with a pulley in between the masses. A full Atwood machine is a two-body system where both masses are freely suspended across a pulley. In an Atwood, the force applied is due to gravity acting on the larger mass. This is again like a tug-of-war. In our example to the right, mass 2 would win the tug-of-war over mass 1. 8 kilograms is greater than 3 kilograms. We will calculate acceleration and tension in grade 11. Here's our Atwood machine. Here's the forces acting on mass 1, force gravity and force tension. Here's the forces acting on mass 2, force gravity and force tension again. Just like half Atwoods, we can draw a full Atwood in a single plane. Since the frictionless pulley simply changes the direction of forces, and therefore the direction of acceleration or velocity. It's important to remind you again that although straightening the system out in one plane makes it easier to calculate net force, it is imperative that you refer to your original drawing or the free body diagram to ensure the vector values have the correct direction. Here is the Atwood machine straightened out in one plane. Here are the forces acting on mass 1, and here are the forces acting on mass 2. Please note that although force tension 1 and force tension 2 seem to be pointed in the same direction, when we straighten the Atwood machine out into a single plane, we see that they are actually in opposite directions. The same goes for force gravity 1 and force gravity 2. Let's calculate acceleration of this Atwood machine. Who wins the tug-of-war? It seems like mass 2 wins the tug-of-war. Let's redraw the Atwood in a single plane. As you can see, the objects move to the right due to the larger mass of mass 2. Therefore, F net is force gravity at mass 2 minus force tension at mass 2 plus force tension at mass 1 minus force gravity at mass 1. There is no friction as the pulley is ideal and the masses do not touch any surfaces and we are ignoring air resistance. Since tension is equal but opposite, they cancel one another out. So we have F net equal to Fg2 minus Fg1. Force gravity is simply m times g, making F net equal to mass 2 times g minus mass 1 times g. F net is equal to mass times acceleration, where mass is the mass of the entire system. So subbing F net out, we get mass 2 plus mass 1 equals mass 2 times g minus mass 1 times g. Acceleration equals mass 2 times g minus mass 1 times g divided by mass 2 plus mass 1. Subbing on our values, we have acceleration equals 8 times 9.8 minus 3 times 9.8 over 8 plus 3. Acceleration is 78.4 minus 29.4 over 11. A is 49 over 11. Acceleration is 4.45 meters per second squared. If we refer back to our original drawing, we can see that mass 1 accelerates upwards at a rate of 4.45 meters per second squared, while mass 2 accelerates downwards at a rate of 4.45 meters per second squared. What is tension in the wire? Recall, when calculating tension, we can use either mass individually. The only value to consider for the entire system is acceleration, as both masses will accelerate at the same rate but in opposite directions, at 4.45 meters per second squared. Let's use mass 1 for our first calculation. We will calculate tension by using the technique that has F net as the sum of forces. F net is force tension at mass 1 plus force gravity at mass 1. Isolating for tension, we have force tension at mass 1 equals F net minus force gravity of mass 1. Remember, F net is ma while Fg is mg. Subbing in, we get tension at mass 1 equals to mass 1 times A minus mass 1 times g. Tension equals 3 times 4.45 minus 3 times negative 9.8. Tension is 13.36 plus 29.4. Force tension at mass 1 is 42.8 newtons. Our diagram shows us that tension at mass 1 is upwards, making it positive 42.8 newtons. Let's check this calculation by using mass 2. We will use the tug-of-war analogy for this mass. Since mass 2 drops, gravity must win over tension. F net is force gravity on mass 2 minus force tension at mass 2, winner minus loser. Isolating tension, we get tension equal to force gravity at 2 minus F net. Remember, Fg is mg and F net is ma, so subbing those in, we have tension equal to mass 2 times gravity minus mass 2 times acceleration, which we had calculated earlier. Tension is 8 times 9.8 minus 8 times 4.45. Tension is 78.4 minus 35.6. Force tension at mass 2 is 42.8 newtons. Looking at our diagram, we recognize that the tension at mass 2 is upwards, so it deserves a positive sign, making it positive 42.8 newtons. Force tension at mass 2 has the same magnitude as force tension at mass 1, simply with a different direction.